What's up, Glenwood? This is naming and writing ionic and covalent compounds. If you want to follow along with me, I would, if I were you, go to mrwiedeman.com right now, and I would look for this the worksheet of the same title as what you're seeing right here. That would be this guy. Now, I have the ionic compounds in green and the covalent compounds in yellow. I'm going to be walking through how to name all of the ionic compounds first, then write them, and then we'll do the same thing for covalent compounds. So I'm just going to kind of go through the worksheet and show you what we're going to be doing here. At the very end, there's practice, so if you just want to fast forward to the practice, you can pause the video at any point in time, try them, and such. So let's go ahead and start. Naming ionic compounds. The first thing that you do is you write the name of the cation, which is the positive ion, first. Then write the name of the second anion and change its ending to IDE. These are called binary ionic compounds when there are two elements. And these are the rules, and this is going to turn into this. For example, this is the element sodium, and this is the element chlorine. And I got those, and I know what they are because I am using my periodic table. Na is right here, so that's symbol sodium. And on the far right, that is chlorine. Following the rules of naming an ionic compound, all you do is you take the second ending of this word and change it to IDE instead of chlorine. So instead of chlorine, you are changing it to IDE. Okay? That's how easy it is to name binary ionic compounds. That's it. Naming compounds that contain a transition metal. This is where it gets a little bit more tricky because you have to tell the charge of the transition element. Here's the reason why. It is really easy for you to figure out the charge of metals using a periodic table. I'm going to show you a trick here. Anything in group 1 has a +1 charge, except for hydrogen. Any metal that's in group 1 has a +1 charge. Any metal that's in group 2 has a +2. Any metal that's in group 3 has a +3 charge, so any metal, that's going to be these guys right here. All the rest of them, the nonmetals now, the green and the yellow guys, they're going to have charges -4, -3, -2, -1, and then 0. That's a 1. 0 on this column because these are noble gases and they don't want to react with anything. They have a stable octet or octet rule. They have 8 valence electrons or 2 filling their outer level. So anyway, this is just an easy way for you to find charges. So copy this over to your periodic table and memorize them. It starts off being +1, +2. You skip this block, then it goes +3, -4, -3, -2, -1, 0. Now a transition element is any one of them that fall underneath aluminum down here, underneath the ladder, and also in the transition block, which is where this is. Any element that falls in here has multiple oxidation states. So for example, let me pick one of these guys. Iron right here. It can be +1, +2, or +3 at any point in time of the day. It depends on whatever you're looking at. So it has multiple numbers that it can be. Therefore, you have to identify with a Roman numeral the charge that a transition metal has if it's in an ionic compound. That being said, let's get back to this worksheet here. So, naming an ionic compound containing a transition metal. Number 1, write the name of the cation first. Number 2, write the name of the anion second and change its ending to IDE. So far, this is very similar to this guy that we just did up here. Number 3, figure out the total charge of the anion on the negative side, and then copy it over to the cation side, which is the positive side. Indicate the charge of the atom using the Roman numerals. Just memorize these because if you devote them to memory now, it's going to save you a lot of headaches later. Okay, so Roman numerals is basically an I for 1, 2 I's for 2, and so on. IV for 5, V for 4, IV for 4, V for 5, VI for 6. So here's what I mean about find the charge of the right side and then copy it over to the left. You need to look at this compound. How does this turn into this? Here's how. We need to find the charge of an individual oxygen atom. That is going to go back to our periodic table. Oxygen is found right here. And the number above it, the charge that any element in this group has, is -2. So therefore, each individual oxygen has a charge of -2. If I have 2 of them, multiply it by that. It was originally -2 for 1. Now this total right side of the compound is -4. I'm going to do dashed lines to kind of separate the compound. If this charge over here on the right side is -4, you want it to equal 0, okay, which we'll talk about later. But for now, you want it to equal 0, so copy this over to the other side. This other side has to be +4. And since there's only one Fe here, that means that this is going to be iron 4 oxide, because this iron has a charge of 4, so we include it. This iron has a charge of +4, therefore Roman numeral for 4 is this. We include it in parentheses, noting that this iron has a charge of +4, oxide, being that it's the name of the compound, ending in oxygen. The next part, naming ionic compound containing a polyatomic ion. Polyatomic ions are found on the back of your periodic table. So from here, on a page called the ion formula chart. Now, on this chart, it's basically doing the whole thing that I showed you, the shortcut that I showed you with the numbers above on the periodic table. This just lists them all out in their own column. For example, anything that has +1 is found in this column here. Anything that has +2, found in this column. +3, +4. Now there are these things right here called polyatomic groups that look just like this. It is a group of atoms that have a charge, whether that be positive or negative. So this group right here, the whole entire group, NH4, has a charge of +1. Going on the bottom of this chart here, anything in this group has a charge of -1, -2, and -3. Now note that there are actual groups here. So this is called acetate, this group, C2H3O2. Acetate is the name of the group, and it has an overall charge of -1. For this one here, carbonate is CO3. It has a charge of -2. Let's see, phosphate. This group is PO4, and it has a charge of -3. So basically, a polyatomic ion is a group of atoms that have an overall charge. Whether that be positive, there's only one that is positive, or negative, which there's a lot that are negative. Back to here. What you do to name one that contains a polyatomic ion is you write the name of the cation first. So if the cation is a single element, write its entire name, just like you did above. You wrote the entire name up here if it was a single element. Then, if the cation is a polyatomic ion from the back of the periodic table's ion formula chart, write its name. So basically, it's just asking you, if it's a group, find it on the back of this page and then find its name. For example, if the group we were looking for was CN, both together, that group is called cyanide, and we would write its name. Write the name of the anion second. If the anion is a single element, change its ending to IDE. Very similar to how we did this one. We changed it to IDE. If the anion is a polyatomic ion from the back of the periodic table's ion formula chart, write its name without changing it. So again, we are finding it down here and writing its name. What I said earlier is that if it begins in something, this is a cation. So this could begin something. This could be a polyatomic group in a compound. It could be this, or it could be this. Basically, you just have to find it and put it in its right place. So let's go ahead and take a look at this compound. This is Na and then OH. Well, that's more than one element, so we're going to call that a group. That is a polyatomic ion. So I know what this first element is. That is Na, and if you don't know the name of Na, you look on your periodic table, sodium, Na. And OH, I do not know what OH is, so I'm going to find it on the back of my table here. And if we go down, bingo, there it is, hydroxide. That is the name of the compound with OH in it, or a polyatomic group with OH means hydroxide. So all we do is we just hook them together, sodium hydroxide. That's it. You don't do anything with charges, nothing with numbers or anything. So let's start writing these things. Writing ionic compounds, writing formulas for ionic compounds. Basically, you want the charge to equal 0. The left side of a compound has to have the same charge as the right side of a compound, and if it doesn't, you have to adjust the numbers of each until you have 0. Okay, because that is going to be a correctly made ionic compound. So here's how you do it for simple ones. Find the charge of the cation. Find the charge of the anion. Adjust each number until you get a charge of 0. So here's what we're going to do. We're going to find the charge of magnesium and then find the charge of bromine, because that's what it means. Just change it backwards again. We changed it already, IDE, to put it in here. So this is bromine on the periodic table. So let's find the charge of magnesium. Magnesium is right here. It is in group 2, so it has a charge of +2. Bromine is all the way on the right side of the periodic table right here, and it has a charge of -1. If I were to add both of these two numbers together, I do not get 0. Basically what you want to do is you want to make them 0. So on the left side I have +2. On the right side I have -1. I want to have this equal 0. So in order for this to be 0, this should be +2 -2. Therefore, I want 2 of these bromines. So I put MgBr2. That's the reason why. Because each individual bromine has a charge of -1, but I have 2 of them, so this side is -2, and a single magnesium is +2. That equals 0. That's a correctly made ionic compound. Moving forward to writing compounds containing polyatomic or containing transition metals, this is even easier. Find the charge of the cation from the Roman numeral. If it's a transition element, it's going to tell you the charge with a Roman numeral. Then you find the charge of the anion and adjust each side until you get 0. So for example, this Roman numeral tells you what charge it is. And if you don't know your Roman numerals, so it's 2 I's. So 2 I's is 2. Therefore, iron 2 has a charge of +2. Oxide means a single oxygen atom. That is right here. Oxygen has a charge of -2. Since +2 -2 equals 0, I only need 1 of each. Therefore, it's FeO. Writing formulas containing a polyatomic ion. You find the charge of the cation. If the cation is a single element, find its charge like normal, like we did before. If the cation is a polyatomic ion from the back of the periodic table's ion formula chart, locate its charge. What I mean is that if you see a group, let's do the OH one again. If you see this OH in your compound, find its charge. It tells you right there. It's -1. There's no number, it's a -1. Or you could look at the top column. That's -1. So let's pick another one. This one, sulfite, SO3. It has a charge of -2. That's what I mean about find the charge. Then you find the charge of the anion. If the anion is a single element, find its charge like normal. If the anion is a polyatomic ion from the back of the periodic table's ion formula chart, locate its charge like I showed you and adjust the numbers until you get 0. So watch this. Magnesium, that's a single element. We can find that using the periodic table. Therefore, let me take a look at that. Magnesium is found right here. It is in this group. The group has a charge of +2. Carbonate. Never heard of that before. Go to the back of your periodic table and see if you can find a group called carbonate. When you do, you find it sitting here. Carbonate is CO3 with a charge of -2. So here's what I'm going to do. -2. Since I only need 1 of each, I'm going to go ahead and write them. So I need 1 Mg, so that's Mg. Carbonate was CO3, so I just include 1 of that group, which is CO3. Therefore, this is +2 -2, that equals 0. Those are all of naming and writing ionic compounds. Covalent compounds, which are these yellow guys, are a lot easier. So let's take a look at those. Naming a covalent compound, you write the name of the first element, and then you write a prefix in front of it if it is more than 1. And you memorize these prefixes, okay? That'll help you a lot. 1 mono, 2 di, and so on. Then you write the name of the second element, you change its ending to IDE, very similar to how you named ionic compounds. You change the second element to IDE. Then you write a prefix in front of it, indicating how many there are. For example, this is the element nitrogen, this is the element fluorine, so this is going to be nitrogen fluoride before we do anything. You see that those things are there. Nitrogen fluoride. Now we just see how many numbers there are of each. There's 2 of these N's. The prefix for 2 is di. So this is dinitrogen, and this is a 5, and 5 is pentafluoride. Easy. Writing the formulas. If you are given the name of a covalent compound, this is how you turn it into a formula. You write the name of the element's symbol, the first element symbol. You use the prefix to identify how many of that element you need. Then you write the name of the second element, and you use, or the symbol of the second, sorry. symbols this time. You use the prefix to identify how many of those you need. For example, what is the prefix for tri? Tri means 3. Tri what? Trisulfur, S3. Tetrabromide. This is the element bromine. Tetra is the prefix for 4. I need 4 bromines. Easy. Just a few hints at the bottom here. If there are no prefixes, then the number is 1. So if it was just sulfur tetrabromide, then we would get rid of this 3. We'll see more of those in the example problems on the back. And also, hint for all future homework. Diatomic elements are non-metal elements that are found as molecules in nature and never by themselves. And they are 7 of them. And they kind of make a convenient little 7 shape. So it is hydrogen, and then these guys, nitrogen, all the way down to iodine. If you ever find these in nature, or if you are writing them into a problem, and it says, use hydrogen. Hydrogen is the symbol H. Well, no, it's a diatomic element, so it's the symbol H2. If you ever have a sample of oxygen gas, it's O2. If you ever sample of bromine, it's Br2. That's just for future homework, so heads up about that. Diatomic elements. Here's where the practice kicks in, finally. Naming ionic compounds. Let's do this one right here. AlBr3. We're just naming them. We don't have to do anything with the charges or anything just yet. So, naming ionic compounds, I need to list the name of the first metal, or the first thing, and then find the name of this and change it to IDE. Al is aluminum, right here, aluminum, and Br is bromine. I'm going to change it to IDE, so this is going to be aluminum bromide. Aluminum bromide. Take a look at the next question. Li2O, that is the element lithium, and that's the element oxygen. So this is lithium, and this over here is oxygen. Change the ending to IDE. This is going to turn into lithium oxide. Moving on, transition metals. You have to tell me the charge using a Roman numeral for the element that is a transition element. So for example, TIS. Ti is found right here. It is inside that block on the periodic table I told you that has multiple charges. So you have to tell me the charge of titanium. Here's how you do that first. You have to find the charge of the right side and then copy it over to the left. A charge of a single S is here. The charge of a single S is -2. I have 2 of them, so therefore that side is -4. Copied over to the left. It has to be +4. Therefore, using your Roman numerals, you don't know what 4 is. It's this with the IV. So this is going to turn into titanium 4 sulfide because we're changing sulfur to sulfide. Titanium, parentheses, IV for 4 sulfide. Next one, PBN. PB is lead, and that is found in the same transition block on the periodic table. That is all the way down here. So that, even though it's underneath this little stair step, it is still part of the transition elements. So the transition elements are any of this block and anything under this little stair step, excluding aluminum. Aluminum is not a transition element. Anything under here, that's a transition element, so therefore we got to tell its charge. Find the charge of the right side first. N is found right here in this group. It has a charge of -3, so this is -3. Copy it over to the left side, +3. There's only one PB, so this must be lead 3, and this is nitrogen, turns into nitride. Lead 3, symbol for 3, nitride. Naming ionic compounds containing polyatomic ions. You need to use the back of the periodic table to find anything that looks like a group, which you can see here. I underline them. Those are groups, polyatomic ions. You need to use the back of the periodic table to find their name and eventually their charge. So anyway, let's go ahead and find this. Mg, I know what that is. That's an element off the periodic table, and that's right here, magnesium. NO3, never seen that on the front of the periodic table. That must be on the back. NO3 is what we're looking for. So continuously look, there it is, nitrate. So the name of this group is called nitrate. You do not change the ending of this word at all. If it's a polyatomic ion, you just write the whole entire name. So this turns into magnesium nitrate. Done. You never change the ending of a polyatomic ion. You use its entire name. So nitrate is the name of this group. This one right here, NH4, that is a group on the back of your periodic table, and that has a charge of +1, but its name is ammonium. NH4 is the group ammonium. And this guy right here, that's bromine. So we're going to change the ending to bromide, IDE. This turns into ammonium bromide. Those are really easy to name. Writing ionic compounds. Here's where you have to find the charge. So here are two elements, it looks like, lithium and sulfide, which turns into sulfur. So we need to find the charges of these things. Lithium is right here, so that is a +1 charge. Sulfur is over here, that's a -2. So this is +1 and -2. I want that to equal 0. Right now it doesn't. I want this side to be +2. If that is going to happen, I need 2 of these Li's. So this is Li2S. Calcium oxide, that is the element calcium, which is found in group 2. And oxide, which is oxygen, is found in -2. This is +2, this is -2. I need 1 of each, so the compound symbols are CaO. Writing ionic compounds with transition metals. Whenever you see these things and you're making an actual compound, you can use them really easily. Take a look at this. Iron 2 means it has a charge of +2. Cobalt 3 means it has a charge of 3. I knew that because I know my Roman numerals. Oxide is oxygen. Oxygen again, charge of -2. That equals 0. So therefore, I'm going to write the symbol for iron, which is Fe. I need 1 of those and 1 oxygen. This is FeO. Next one, cobalt 3, and this is bromide, which is the element bromine, and I need to find its charge. So bromine is found right here in this group. It has a charge of -1. I want this to be -3, and I can make it that way if I have 3 of these guys. So this is the symbol, CO. Cobalt. I looked it up on the periodic table, and you could find it if you don't know what anything is. That's cobalt. That's how I knew that. CO, bromide. Br3. I want 3 of them because that'll make it equal 0. So that's +3, that's -3, that equals 0. This guy is +2, -2, that equals 0. You always have to make them equal 0 when you're actually writing ionic compounds. Polyatomic ions, you got to find the charge of these guys on the back of the periodic table. So this is sodium phosphate. Sodium, I know what that is. That's over here. That is a charge of +1. Phosphate, that's not on the front of the periodic table. That must be on the back. Phosphate is found right here. It has a charge of -3. It is PO4 with a charge of -3. So therefore, that does not equal 0. I want to have 3 total of these. I write sodium symbol, which is Na. Put a 3 afterwards, and I need 1 of these groups, PO4. Calcium hydroxide. Calcium is in group 2. It has a charge of +2 right here, calcium, +2. Hydroxide is not found on the front of the periodic table, so it must be on the back. Hydroxide is right there. It is under the -1 column, so it has a charge of -1. And its symbols are OH. Calcium is +2, and that's -1. So this does not equal 0, and I want it to, so I'm going to need 2 of these guys. Whenever you need more than 1 of a group, you need to put parentheses around it when you're actually writing the formula. For example, Ca, I need one of those. Now I want two of these. Parenthesis, put the thing inside that you want more than one of, and the number on the outside indicating how many you need. That is writing ionic compounds. Writing and naming ionic compounds. This last page right here is covalent. These are very easy. Just by saying how many there are of each, or looking at the prefixes so you can see how many there are. For example, B2Si. First off, let's find what these elements are. B is all the way on the right side of the periodic table, element boron, and the other element is Si, so that is right here, silicon. Boron and silicon. You're going to follow the same rules in changing the second element to IDE, but now you just write down how many you have. For example, there are two B's. Going back to your prefixes, the prefix for 2 was di. So this is going to be diboron, and there's only one of these, so the prefix for 1 is mono. Monosilicide. Diboron, monosilicide. Let's do the next one. This is the prefix for 2, so that means di. This is the prefix for 6, that means hexa. Go back to your little list and you can see that. This is the element silicon, this is the element bromine, this is going to change to bromide. So this is disilicon hexabromide. Disilicon hexabromide. Disilicon hexabromide. E. Last one, CF4. If there is just one of these things, your prefix for that is mono. Mono. But however, I had to include it for my second element here. You can chop it off if it is just the one, if there's only one element in the compound up here. So you don't need to include, this is not monocarbon, and then this is tetrafluoride. This can just be carbon tetrafluoride. You don't have to include mono for the first element, which is what I'm not going to do. So this is going to turn to carbon. Then the prefix for 4 is tetra, and that's the element fluorine, which turns into fluoride. Tetrafluoride. Here's the last few. Writing the formulas for covalent compounds. If there is no prefix, that means that there's one, but if there is a prefix, find out what it is. For example, I have 1 iodine, there's no prefix. Penta is the prefix for 5, so therefore I must have 5 of these guys. Fluoride means fluorine, so this is going to be iodine, IF5. And again, I only know those because I looked at my periodic table, the symbols. Look at the next one. Di is the prefix for 2. Nitrogen, 2 nitrogens. Tri is the prefix for 3. Bromine, which is bromide. Bromine, I have 3 of those. Finding their elements from the periodic table, their symbols. This is dinitrogen, N2, Br3. Hexaboron monochloride. Hexa, prefix for 6. Boron is the element. Monochloride, there's 1 chlorine. Hexa, B6Cl. That is it. Go back through this video, practice it over and over again, pause it, re-listen to some of the instructions, go to MrWiedeman.com, print yourself off one of those periodic tables, one of these guys, with the formula chart on the back. And that is it, ladies and gentlemen. If you have any questions, feel free to ask during class.